So let me tell you a story about 2015. In 2015, Bitcoin was the thing, and enterprises, I used to work at IBM, and at IBM I was working at Watson, and a guy named Jerry Cuomo called and said, hey, Lewis, it's Clark. There's this thing called blockchain, we gotta go explore it. And I said, well, give me a shipping crew and I'll go check it out. He said, well, I got a canoe, 2 muskets, and a dog. And we started IBM Blockchain, and we started what ultimately became Hyperledger Fabric. And we went around the world explaining in 2015 how to enterprise executives who really didn't get this stuff that Bitcoin is not blockchain. We said, blockchain's not Bitcoin. Everybody said that. And over time, between the early part of 2015 to the end of 2015, we went from nobody wanting to talk about blockchain. In fact, my predecessor, a guy named Paul Brody at Ernst & Young, kind of got a little bit in trouble for talking about Bitcoin and blockchain in the early part of 2015. By the end of 2015, I could say it all the time. The CEO of IBM was saying it all the time. Everybody, we went from no Bitcoin to demanding Bitcoin, or no Bitcoin to demanding blockchain. And it all came down to that mantra, blockchain's not Bitcoin. And while many in the original blockchain community kind of shunned this, some saw it as a natural expansion of the ecosystem. Leaders in the Ethereum community, in particular, supported this period, and currently, in fact, my current boss, Joe Lubin, supported this period of industrial awakening by launching the Enterprise Ethereum Alliance, building products like Kaleido, which is very enterprise friendly, and crafting new Ethereum clients like Pantheon that can serve as nodes for both permissioned and permissionless networks. And the last 4 years has seen this rising buzz around blockchain, and it's prompted companies to prioritize collaboration, fund long overdue digitization efforts, and extend digital business process management across corporate borders. So, I don't know, for those of us who remember BPM and, that sort of business process management going from internal company systems to cross-company systems. Boring but important, and it's starting to happen. We're experiencing a resurgence in enterprise system integration. This is a good thing. But industry leaders today largely think about, it was partly my fault, they largely think about blockchain in terms of networks. Now, public ones versus private ones. That word in the middle is the part of the problem, versus. It's an oversimplification, and it tends to generate poorly conceived projects which struggle to show significant value add. And this has fostered some skepticism, and it's already leading some in industry to conclude, they've got a little heartburn, falsely, that blockchain projects should be put away and forgotten. So we got to fix this. There's always something to fix. Fortunately, now there's a new wave of credible leaders showing how to think about blockchain outside of that network box. Communities like Chainlink, startups like OpenLaw, one of ConsenSys' companies, wonderful company, and enterprises like Microsoft and Ernst & Young, which just announced Nightfall, which is quite an interesting, completely public, not just open source, public domain project. You don't even have the Apache 2 license, it's public domain. I'm gonna start doing almost all my stuff that way too, by the way. So you can, I'll talk about my team in a minute, but effectively, my business model is come steal my car. So, and not only steal my car, drive my car and lead my project, right? So don't make it my project anymore. I win when it becomes your project, right? This is something that we kind of pioneered with Hyperledger. IBM took 40,000 lines of code and gave it to the Linux Foundation. And in spite of the fact that there's some folks who have dogs in the hunt that try to make that out still to be an IBM thing, legally and in every other way, we gave that away. We didn't want it. Ernst & Young went even farther. They public domained the entire piece of work. And this was all showing how to use Ethereum mainnet in practical ways that make it easier, safer, and efficient to integrate specific functions across different corporate systems without, and this is the key, without exposing private information or confidential business logic to unauthorized parties. So the problem here, in order to follow their lead and reach this next level of blockchain maturity that we must achieve in the next couple of years, or people are really going to lose steam over this stuff, we have to fix two big misconceptions. One, this blanket notion that private permissioned blockchain networks are more secure than traditional database technology or mainnets like Ethereum. Two, the belief that the public mainnet is inappropriate for use in confidential business operations. Those two beliefs are wrong. They're dangerous, and they prevent us from seeing the practical opportunity that the mainnet offers to put an end to a half century of Byzantine, balkanized, and bespoke system integration. Simple as that. First, while permission blockchains have some good uses, many good uses, they're not a security panacea. I think this is a big problem. People think, oh, well, I don't like the word public blockchain. I think I'll just use a private one, because that'll be private, and I like private. No. Private blockchains, public blockchains, all blockchains are nudist colonies. When it comes right down to it, they're digital nudist colonies, whether you're on a private beach or a public beach. If you have access to the beach, you get to see everybody in their birthday suit. That's a blockchain. Great things about it, but you need to know what it is. You know, cryptography is like wearing a Speedo. You know, it doesn't leave a lot to the imagination. I got a joke. So that was, so previews are working. That's good. I'm working on the timing. Right. So they're not a panacea for this stuff. You have to understand that security really is about two things. It's about surveillance resistance and tamper resistance. Blockchains can be good about tamper resistance. They are basically terrible about surveillance resistance. And really, if you think about it, most CEOs that you talk to, they're worrying about data breaches. They're not worrying about tampering. And they're especially not worrying about their own people tampering. They love it if their people can tamper. If you talk to a CEO who wants to do blockchain and they say, the biggest thing I want to make sure of is that my own company can't change history, then maybe they get it. And maybe they should be working on blockchain. So just to illustrate this, if you take the number of system administrators from different companies with different security models, with access to your private blockchain network or running a node on your private blockchain network like Hyperledger Fabric, less so Corda. Corda's better at this. And you multiply your normal risk of a data breach by that number. Because as Mr. Robert will show, showed us on TV, the best hack are people. Right? So if I can compromise any one of those system admins, I have access to the ledger, which means I have access to what's going on that ledger. And if that stuff is sensitive information, it doesn't matter that it was a private blockchain, right? It doesn't matter. So you have to know what tool you're working with. Tools sort of have their own intentions, and blockchains like to spread knowledge. I think the reason, by the way, I think that this happens is that we mistake the maintenance of the integrity of the ledger, which can be permissioned or permissionless, with what you're doing on the ledger, which can be between known parties or unknown parties, right? So Bitcoin, you might want to, as a statement, not be known when you're buying your drugs or what have you, when you're doing naughty things. And that's great, but that's not. In fact, Ethereum was founded by people who believe, and I think this is correct, that over 99.9% of transactions will be between not only known parties to each other, but parties that have rigorous verification of their credentials. So you can be a known permissioned actor on a public blockchain just fine. Even though the maintenance of the integrity of the ledger can be done by anybody. Right? So this is a misconception that it needs some nuance. So now that we've learned to spell blockchain for the last 4 years, now maybe we can move up the maturity model even with CEOs and CXOs. So the second thing is that while it's true that enterprise blockchains are somewhat more secure against record tampering than a single party system, they are still subject to collusion. One word, LIBOR, it happens, right? If a bunch of banks find it in their interest to change the record, I think they can do it if they have control of the system, even if it's a bunch of them. It's a little less it's a little more tamper resistant, but it's not where for a lot of things, that's not where you want to go. You want something that is as close to tamper resistant as you can get for some things. Small private blockchain networks aren't that, but the mainnet with the scale and governance of Ethereum might be, and that's just math. So if the priority of your solution, enterprise solution, is both security against unauthorized surveillance and security against tampering, then you need to use the right tool for the right job. You need to store your data on well-understood end-to-end encrypted systems and use something that offers military-grade tamper resistance when you're passing verified messages and proofs between parties that need to know that you're playing by the rules. So right tool, right job. You need private, air-gapped traditional relational database for some things that, well administrated for things that you absolutely can't let get out in the open. Even now, even though that's the best that we have, that's still, we hear about great hacks, right? Putting it on a blockchain doesn't solve that problem at all. It makes it worse. But using a mainnet as, and I'll talk about this quite a bit in a minute, as a message bus between systems, now you can get the mainnet's tamper resistance and confer it onto your private state machines. Who here, by the way, who's an executive? Who's a developer? Yeah, so we got a pretty technical crowd. So I'll get a little more technical than I was going to plan on doing with this speech. So imagine what a game of cards would be like if everybody played with their hands face up. A pretty boring game. That's what a blockchain is like. Most games worth playing orchestrate what's shared and unshared. And this goes for what's printed on the cards as well as the strategies and tactics. So it's not just about data. It's about business rules. It's about code. It's about, in blockchain speak, smart contracts, right? If I know enough about those tactics, if I know the rules of how you're arranging the cards in your hand, I might get a pretty good idea what cards you have. I certainly might get a pretty good idea about your strategies, right? I can't do that. In business terms, think of the cards as data and the tactics as functions or smart contracts or just functions. If a competitor knows those, not so good. And even in an alliance, in a blockchain network or a consortium, you want to be careful about who knows what, when they know it, and under what conditions, because today's partner may be tomorrow's competitor, right? Bridge. Let me close this idea with the game of bridge. Anybody play bridge? Yeah, okay. So here's the nutshell. I've got bridge down to like 2 sentences. So a card game, it's similar to spades. 4 players divided into 2 competing partnerships. Each player, 13 cards. The partners use cryptic signals during an auction round to coordinate on their 2 hidden hands. And then cards are revealed in turn. And the high card of the appropriate suit wins the trick. It's a tactical game. It's a game of chance with restricted communication, which is a pretty good way of describing a lot of business. In IT terms, you have a bridge player's hand is like a unilateral state machine. It's my machine. I don't want to put that on a blockchain. If I was on a blockchain, everybody who had access to that and who had to validate my function would know my function, could decompile and figure out what my function was. Don't want that. Certainly don't want them to know what my cards are. But now I've got to signal you and I are going to figure out that we should be playing spades, right? That's how we're going to play this hand. But the 2 people who are competing with us really shouldn't know that information. Again, not a good idea for a blockchain, and a two-party blockchain is not a blockchain, right? It's a state machine. You can do it with a peer-to-peer, DHT, but you can't do it with a blockchain, not with a consensus-based mechanism in it. And then I'm going to throw a card. Now I've got an ace on the table. Now we have shared state, right? Now we're all sharing the information that we have. And that could be on a private blockchain, public blockchain, whatever is appropriate. But you see how we need to have an interplay between different kinds of state machines where we have some information in one, other information in bilaterals, other information in multilateral. And then finally, ultimately, maybe we're playing in a tournament, that might be the public network. So each player needs to be managing their own private machine. And at the start of the game, we need to simply entangle these machines so that they're able to play together, but be incapable of breaking the rules, or at least would be found out before the game is ruined. And we don't have time enough to go into details about this, but I'm happy to talk offline about some of the issues around that, right? Sometimes a rule, I need to prevent you from breaking the rule, putting an ace into your hand, or maybe I can do that at the end because we're all gonna, you're gonna get caught at the end. But maybe the game is ruined right at that, right in the middle, so I have to verify and get a proof that you're playing by the rules, that your system is compliant before the next round of the game or before the next piece of workflow happens. Different things in here, and we don't have time to go into it all, but I think you get the idea that we have coordination requirements. So, using the mainnet as a magic message bus is sort of my argument. That if we're going to do that sort of thing, if we're going to play bridge on any kind of network, what we need is a common frame of reference. The last I checked, unless the laws of physics have changed overnight, you need a common frame of reference to make all of this stuff work. And we used to have one of those. It was, we built systems like that in the 90s and before and since. We have message queue, and we have RabbitMQ and MQ series, and we have other ways of doing loose coupling of different systems. Who hasn't written a pub sub, messaging, right? This is something we know how to do. Problem with some of these, though, is that they're very brittle, they're very tightly coupled, you have to have the same language, or you have to be running on the same VM. You can't just be passing messages. So wouldn't it be nice if we had a big message bus, a big board, a bulletin board, where I could take my ace and write ace on a Post-it note and put a sticky on it and then say, here's the topic, and I throw that onto the message board, and my partner knows to be watching for that label and says, okay, we have, I guess we're playing trumps or what have you. Then we throw a card, and that's put on the message board. Now we all have a common frame of reference. Now, anybody who's technical in this room has 1,000 questions because you're going to say, wait a minute. A mainnet's too slow for a lot of that stuff, and the answer is right. And then somebody else will say, a mainnet is too inefficient. And I'll say, yeah, just like the internet was in 1992, when we started, those of us who were doing system integration at the time went, oh yeah, we'll always have a job because the internet's a terrible way of passing packets, right? Well, no, 2 or 3 years later, we found that just being able to do it the same way over and over again and using that common resource was a lot better than having to build it bespoke every time. So again, what we need to do is get past Byzantine, bespoke, and complicated system integrations. So my argument is, at the end of the day, 1 minute to go, is we're going to start in the next year seeing more and more maturity around ways to use the mainnet as that common frame of reference. And to be clear, I'm talking about the mainnet as the full construct. I mean, we're evolving the Ethereum mainnet. It's getting sharding. It's getting scaling. It's getting plasmas and layer 2 and side chains and state channels. That whole construct that ultimately uses the whole world. Anybody can participate in the maintenance of the security of the system. We can use different shards of that around the mainnet to be able to get some finality faster, get more assurance of finality, slower, we can choose. Ultimately, that's what I mean by the mainnet. And using the mainnet as a magic message bus as a way of doing loose coupling between enterprise systems, I think is really a boring idea, but it's a really good one. I think I'll stop there. Thanks.
So the message bus infrastructure you mentioned, is it like a public Kafka?
Public Kafka would be one way to look at it, right? So this is I'm not talking about fancy atomic swaps. I'm talking about placing a message on a bus. Right? So I think the hardest thing I've been trying to struggle with getting this message across is how dumb simple I'm trying to we're getting to. I'm not talking about, and maybe a proof to make sure that the message you put on there actually came from a machine that is compliant, right? So that function, maybe I have a library where that function has already been pre-vetted, and I can pass a proof that library was executed when in generating the message. And now we have to get into race conditions, deadlocks, all these other things. So there's a lot of tooling that needs to go on to make this a complete system. And there are organizations like Cosmos and Polkadot and other things that are working on this. My argument is, that's great, but I want that message bus to be as decentralized as possible so that the connective tissue in the stateful internet that we're getting to is not ever in a position where it could get controlled by a small group of people. Right? I don't mind if my enterprise system is controlled by my enterprise. That's okay, as long as the connective tissue that allows it to work together with something else, break out of this network box, that stuff should be decentralized. Thank you.